it accumulates as it goes, and then it magnifies. We call that biomagnification because the little organism eats it, a bigger organism eats it, and then a much bigger organism eats it. So it goes along the food chain. And where do these plastics come from? Our everyday activities, right? So our shampoos, our Vaseline containers, our water bottles that we eat from, our plates, and then the factories, washing machines, they produce, when you put your clothes in, they are producing fibers especially. And all these end up in our environment. And the big issue is more about the materials that these plastics are made up of. So that's what you see in the red letters. So PP, polyethylene, or PVC, like the normal PVC we use to build our homes and all that. So those are the materials that are in these plastics, which make them even more dangerous. And how do they end up in our environment and water bodies? When we drop these items from our home, so you are sitting in a car, you drink water, you just throw it out of the window, and you are doing other stuff that you don't properly dispose of them, they eventually end up in our environment. And then they circulate throughout. The impacts are enormous, so it's affecting our health. The fishes, I've already talked about that. It affects their energy levels. It affects their reproductivity. Human beings, there have been studies that have found out that it's in our bodies and it's doing a whole lot of harm. In fact, a study that was done in Italy about 3 years ago, and then published, they did a study, collected like unborn babies. They took some of their fluid, and then they looked under them, and they found microplastics in six of these unborn babies. So even before they come into this world, we are already polluting them. And imagine what these will have and these plastics in their body will have impact on them. Another study has shown, for example, for men, reproductive health, they took semen from men and they analyzed them and they found microplastics in them. So there's some studies are showing, but it's not been proven yet, that could even lead to sterility in men. But it's yet to be proven, but that's the hypothesis. So the plastics are all over, and we all drink water. We drink from our tap, from bottled waters. There have been studies that have gone to grocery stores, bought bottled waters, take them to the lab, and they found microplastics in them. So even the water that we drink that are supposed to be filtered are actually not. They are ending up in our body. The beer that you drink, the air, the seafood, the honey, salt, sugar, all of these have been studied, and they found plastics and microplastics in them. And humans, as I mentioned, they go through our digestive system, our skin, our kidney. All of these are infected. So it's not just the material you're looking, but as I mentioned, what they are made up of, like those things I showed. So you are looking at PVC, polyvinyl chloride, or you are looking at PP, polypropylene, and all this. Those are the chemical materials that are getting into our bodies. Our sewage treatment plant. So our water, we use the bathroom, we flush, or we shower, we flush, and all drain into the gutters. They go to sewage treatment plants, but unfortunately, they are not treated well because it's so expensive to treat these. So a lot of governments or local government assemblies they put some amount of money in it, but not to the way it's supposed to extract all these plastics before they end up in our environment. So all these are sources. So you've seen how they come from rain. They are coming from our drainages, our washing machines, the equipment that we are using in construction like PVCs. Every sphere of our lives are producing plastics which are damaging our environment. So here is one study that was done here in the Mississippi River in the Great Lakes, which are some of the biggest water bodies that we have here in the US. And they found these very, very worrying statistics about one particle, every 8 gallons of the Great Lakes water that they took, they found one particle in it. So virtually it's everywhere, nobody's escaping. And I mentioned seafood. A lot of us eat seafood, and especially for us from Africa and West Africa for that matter, our source of protein is heavily dependent on fish. We eat a lot of fish. You mentioned tilapia, salmons, anchovies, catfish, and all. We depend on a lot of fishes for our source of protein because red meat is expensive and is not easily available as we get from fishes. So we are really at risk from us from West Africa. We're also really at risk because we depend on a lot of seafood. And I explained what bioaccumulation meant and biomagnification. So small organisms to big organisms. And the thing about these microplastics being in the ocean too is that, or in any water body, See, they are tiny, so they are suspended in the water. But with time, the plastics are going to sink to the bottom, and some of them will settle to the sediment or the sand. They may be sitting there, they are not gone. So if you have a storm event, okay, it's going to stir up the water and it's going to resuspend them into the water. The fishes are going to eat them and then they come out. So they never go away. Or during upwelling. So those that live along the coast, like if you live in Lagos, Lomé, Accra, you notice that during the summer month, June, July, August, it's colder. And what happens is upwelling because the bottom waters come to the surface. So the hypothesis is that during this time of the year, during the upwelling season in the summer in West Africa, you are going to have all these cold waters that come to the surface because the wind direction have changed. Along with it is all these plastics that suspend. And if you know the phenomenon of upwelling, nutrient-rich water comes to the surface, and it's good for the fishes to tend to eat a lot during the upwelling season because the water is rich, it's producing a lot of photosynthesis, and the fishes are eating a lot. Because that bottom water came to the surface, it carried with it all these microplastics that are also down in the bottom. So we are more at risk when we eat these fishes, especially during the summer months, June, July, August, because that's when the water is productive. The fishes are eating a lot. But that is also when these plastics that are in the bottom get suspended and come up, and then we eat them as well. And it's not just the fishes. There are birds that also fly over the water bodies. They eat on these tiny, tiny fishes. So the birds are also ingesting it. So if you are somebody that also tends to enjoy eating bird meat, that is also there. And then also as these birds are flying over the water, they are pooping into the water. So whatever plastics is in them is also getting into the environment. So you see, it's just one big giant cycle that is going out. And then this is showing some of the impact that these microplastics have on the fishes, how it affects their energy levels, oxidative damage. It changes their DNA. And we talk about changing their DNA, what it means is that over time, you have the situation where the fishes are no longer going to be like they were before. So if you have fishes that had this resistance of being able to stand, let's say, the weather in Africa or somewhere else, their body is going to change so much that down the years, in about 10, 20 years time, their DNA would have been changed by these microplastics so that they won't be able to withstand these environmental conditions. So what will happen? These fishes will start going extinct. And when they go extinct, because we depend on them, we are going to have less fishes, and that the governments will have to look for other sources of protein, or people become malnourished. So we've seen how these microplastics are in the environment. We need to do something. How do we study it? That is when scientists, NGOs, and environmental conservationists come in, like the work that Ms. Adeoke and her group are doing, which is very, very phenomenal, trying to educate people, get the data. But to be able to inform policymakers and then bring about good policies, you need to have data. When you go to a politician and just tell them these plastics are causing problems, they are just going to look at you. But if you have numbers, some statistics to provide them, and they look at it and see how stunning it is that we are finding microplastics in unborn babies, it's going to make people sterile and all that, they may start to take things serious. So that is where the research part comes in. So here I'm showing something that my group here we are doing. So this is a water body that we have down here in Mississippi. So we have this garbage catcher that we put in there, and it collects the trash. So once in a while we go and then bring it out. We try to look at the type of plastics or other debris that are in it. So this is one way that we do it. So how do we collect other samples as well? We can take plankton net, bongo net, and other traps, go out to sea. We tow it on the back of a boat or a canoe over, say, 10 or 15 minutes. And whatever is trapped on these sides of these nets, we take them to the lab and then we analyze them. You can also collect water using a metal bucket, filter it on the boat, and then bring it to the lab, or you put them in bottles like this. And if we want to study the sand, the sediment, we need to have grabs. These can bite into the sand and collect the samples for us. If you're on the beaches or rivers that are not deep, you can also have these metal poles that you dig into the sand, scoop a bit of the sand, put it in your bag, and then go out. Then on beaches also, we can do these studies. On the top left, you are looking at the beach in Ghana, which is right in the capital, La Boma Beach. And this is a place tourists go. So let's say you have your money or you just want to go to a beach to go and relax. You wouldn't want to be in a beach like this. So this is right in Ghana. And then on the bottom, this was in Nigeria last year when we're there, some on the island. And you see yours truly, Miss Adike, and the group also helping to study how we collect these plastics on our beach. So this is how we collect the data. I also talked about microplastics in fishes or crabs or whales and other organisms. So for them, you can get the fishes, you take them to the lab, you cut them out, their body parts, sometimes the GIT, the intestines. Then you put it into a bottle, put some acid on it to digest all the organic materials and retrieve the plastic from it. So with all these, whenever we get the samples, we are in the lab, we do some forms of analysis to it. We prepare the samples, we can do what we call density separation. So plastics have a certain density. All plastics are not the same. Some are heavier than others. So if you get like a sand or a beach material, you need to get the plastic out of it so you can look. So you need something that is heavier than the plastic. So salt, like home salt, for example, is very heavy. So you make a solution, you pour the sand into it. So with that, it will cause the microplastics to suspend because they may be lighter than the salt you have. So that's what you are seeing in this image here. So the plastics come to the surface, you decant it or you filter it, you get the microplastic that are trapped on a small filter paper, then you look under them in a microscope. And that is not all. You need to do chemical verification, which I'll come next. So I mentioned PVC, PP, PE, all those are chemical materials in the plastics. How do we know which ones? We do what we call Fourier transform infrared. And that is putting it under very high resolution microscopes that are able to get a spectral signature. So every material has some sort of signature. And you can match this with a library and it will tell you what this is. So when we are doing this plastic research, what are we looking for? We are looking at one, the shape. And we talk about shape. Is it a fiber? So a fiber is usually like your shirt or dress. Those are typically fibers. Or if you use washing machines, you see that there's a material in there that traps. Whenever you finish washing, you take it out. It's a small net. You see a lot of material that have been cut on it. Those are all fibers. The another shape that is common is films. So films are like the grocery bag, the plastic bags. So you go and buy your very favorite akara or some other food, fried rice, or they put it in some plastic material for you. All those materials have chemicals in them, so we need to be careful. But those are the films. Then you have the foams. The foams, very obvious, like the foams we use at home or we use to wash dishes. Then the fragment. The fragments are the very hard ones. So like the plastic cup, the plastic bowls, all those are fragments. And then pellets. Pellets are very, very notorious for the manufacturing industries because pellets is the raw material that you get into those factories. You can melt them and mold them into different kind of plastics that you want. So usually the manufacturing companies, that is what they use, the pellets. So these are the 5 commonest shapes when we talk about plastic shapes. Then we're also interested in knowing the color. So if you look at the pellet, for example, you see red, blue, green, and all that. Why are we interested in studying this? When you are looking at the impact of microplastics on organisms, you want to look at which colors are very dominant there because the fishes, for example, are attracted by bright colors. So if you have a lot of bright colors in your water, it's going to be more attractive to fishes and they are going to consume. That is why we are interested in knowing the colors. Another thing too is that the colors are put in by the factories that make these plastics. So if they want to get red color, they add a dye. Yellow, they add a dye. So we want to know which colors are dominant in our environment so that we'll know which are the greatest pollutants. And then the size, as I mentioned, microplastics are 5 millimeters to all the way down to 1 micron. So we want to know which size ranges are very dominant in the environment. So we know the impact because the smaller the material, the more likely they are to be consumed by these fishes. So if you have a lot of the very, very tiny ones, then you are going to have more ingestion by the organisms. And then the polymer type. So the polymer type is whether it's a PVC, it's a PE, or the other chemical material. Again, all this will let you narrow down to know the material that are being put into this, and then we do them. So one of the things that I do at my work is to be able to have a broader picture about plastics in a whole environment, we need to collect the data. So the NOAA, which is the National Oceanic and Atmospheric Administration here in the US, which is the government agency that is in charge of all the water bodies. So if in Nigeria, that probably would be the EPA. Ghana also is the EPA. So in the US, we have EPA also, but NOAA is specifically for all water bodies, the atmosphere and organisms, so the fisheries and all that. So why do we need to get a good database? You cannot tell a scientific story without the data. As I mentioned earlier, if you want to go to a politician and all those, you need to have data to be able to make your case very strong. So this is why we need to get the database. We also want to know how much is out there, right? How much is near the coast of Nigeria, South Africa, in the US, Russia, and all that. So we need to know the amount that is there. Then we'll be able to know where most of the pollutants are coming. And I'll show you a short demonstration how these are all relevant to us. And then we'll also be able to do numerical modeling. So modeling is where you're able to use, like, let's say if you're looking at the ocean. If I were to drop a plastic near Accra, where will it end up? I'll show a short video too. If we're able to put all these together, we'll be able to have a very much great story to tell. So the way we created this database is that we look around the scientific literature, like on Google Scholar, Google Scholar, and the Web of Science, and all these places. Or we look through the media, the news items, and we look at who is doing research on microplastics. Excuse me. Then we contact them and we ask for their permission for their data. And if they give us the permission, we put it in our archives, and it's guaranteed to be there for like 75 years. We quality control the data and do a whole lot of different things to it. And we put it into a database. So this is a database I developed for NOAA. And this is accessible to the anywhere you are in the group. It's free. You can download it. If you look at this QR code or you go to the website, you can just go down, or you just send me an email. I can point you to the data or help you download it. But it's freely available. You don't have to pay anything. So this is what we have currently. And we have data in the surface ocean, in the bottom ocean, in the sediment, and then also on beaches. And in the next quarter, what I'm trying to add to it is database of microplastics in organisms like fishes, whales, and sharks. So that's the next step we're going. But for now, we have these ones available. So you go to the website, you click on, you don't need to download everything. You can download everything if you want, or you can subset an area that you just need. And as I mentioned, we need to have this data because we want to know where the plastics are coming from, so we'll be very much informed. So if you look at this image here, this is a model that was developed. So let's say someone is sitting in Nigeria, they drop a plastic, right? They put it right here. Over time, if you look on the top right here, this is time, it's measuring time. You see, even though you are in Nigeria and you drop your plastic, over time, it's going to end up somewhere else. That is what this is. Or if someone is here in the US or somewhere where I am now, if I were to drop a plastic, look at where it ends. Eventually, this plastic is going to float in the water, being carried by the current all the way, and it will end up in Europe. So this is why it is not a one country or one town's problem. It is global, because someone may be careless and drop their plastic, and then we all have to suffer for it. That is what this model is trying to teach us. So if we were to do this, then we need a concerted effort. And that's why the United Nations came in, the United Nations Environment, they are all put into it. And this, they had a big conference somewhere, some years back, and this very nice image. I mean, it's trash, but like it tells the story that we need to turn off the plastic pipe, because it's like we've opened a drain, we drain so much things, we need to close it to stop the release of plastic into the environment. So some countries are doing really good at this. So Canada, Rwanda, India, Kenya, Germany, Norway, France, Chile, Sweden, and Peru. So if you look at Africa, we only have two countries, Rwanda and then Kenya. They are doing so good. I was in Rwanda about a month or two ago, and they don't allow plastics there. At the airport, if you have, let's say, any carry-ons or whatever in plastic, they'll take it and then they'll give you one of these recycle or renewable material for you to transfer your materials into. You go to the store, you buy something, they won't give you a plastic bag, they'll give you a paper bag, because those can easily decompose. So some countries have taken this serious and they are doing very well at it, and others are not. Another way we can curb the plastic menace, and I'm talking about plastic because that is where the microplastics come from. They eventually break down into microplastics. Is circularity. And when we talk about circularity, essentially is about, I mean, the best way is to stop using plastic, but that may be a very long way down the road. But at least for now, circularity, we can go by that, where we make sure that we recycle what we use. So if I were to drink from this bottle, after I'm done, I shouldn't throw it into the environment. It needs to be collected into a recycled material that they can break it down and remake another material out of it. So that's one bottle get to be used severally. It is not the ultimate solution, but that helps because we are not getting the plastics into our environment, which then will harm our environment and harm the organisms in it and eventually harm us as well. So recycling is very important. We also need to be ocean guardians or environmental guardians, in that we need to use less plastic. So there have been calls for having like materials like wood spoons and wood plates, and then material that can be recycled, as you see, or bamboo. There are some cities here in the US, like if you go to the state of Oregon, for example, they have cities there that Corvallis, where the restaurant, they don't allow using straws. Straws are one of the number one pollutants. They will instead give you bamboo straws or paper straws. Some of the airlines like Delta Airline, they will not give you plastic cups, they will give you paper cups. So these are some of the ways that we can use to be able to curb the control of plastics in the environment. So microplastics are everywhere, ubiquitous, everywhere you turn, in our air, in our water bodies, in our sun, everywhere in our clothes. We have them. They are harmful to our environment, the organisms, and we humans also. So we need to do a lot to be able to curb it. And that is what we are doing, and organizations such as Ms. Adiokeke's organization are doing, together with a lot of other environmental places, universities, professors, or scientists. They're all trying to put their hand back. So you can also do a little in your own corner to help curb the flow of plastics into our environment, which eventually harms us and our several generations to come. Thank you for the invitation and your attention. Yes, so we'll be happy to take some questions. If you have any questions, you have some experiences you can share, what can we do? And in your own local community, or even in your own home, what can we all do to be able to curb the prevalence of plastics and microplastics in the environment?
Thank you so much, Professor. Please, if you have any questions, you can raise your hand using the emoji icon, and we'll take your questions right after. Thank you, everyone, for joining. As we've heard, Professor has said it seems like we're in a sad situation that we cannot escape. You know, he has talked about bioaccumulation, biomagnification. So if you say you don't want to eat fish and you're interested in birds, some way, somehow, microplastics, you know, will get into you. And, you know, he has also mentioned the effect of microplastics, and he's not talking from a place of guess. He's talking from a place of concrete evidence. You know, he's talked about how research has shown that, you know, microplastics have been found in newborns, and also have been found to, you know, there's research going on to show that they might be a cause for infertility or sterility in men, right? So this is something that we all have to come together to fight. And as he said, if you want to be a part of it, we all have to speak up. Everybody has to be environmentalist, and you know, you can be an ocean guardian, you can spread the word. And one thing I've learned recently is that no action is too small. I put this together today. I didn't even know that we're going to get, you know, this many people that would join, because usually I was thinking that, you know, webinars are becoming, you know, it looks like it's becoming a thing of the past. And I was thinking, okay, so maybe we can start doing, you know, environmental podcasts. But, you know, and I was like, I'm inviting Professor Iben today. Oh my goodness, what if it's just 5 people? And I said to myself, even if it's just the 5 people that come, that decide that take something away from here and go ahead and create action in the world, it's enough for us. But fortunately, we have more than 5 people here today, and I'm sure that that will create a ripple effect. Thank you all for joining. I'd like to take Paul Alabi's question. You can unmute. Thank you.
I'm greeting everyone. Thank you, Mrs. Ajoke, for the wonderful initiative. Dr. Ebenezer, thank you very much, sir. It's nice to hear from you again. It's Paul Alabi from Western Nigeria. So thank you for the insightful presentation. I believe you can all hear me, please. Can you hear me? Okay.
Yes.
Yeah. Dr. Ebenezer, my question is more related to technological advancements that can complement the use of traditional methods like sediment sampling and water sampling that you mentioned during the presentation. So we know that remote sensing is an interesting area of technological application for Earth observation. So I'm just curious to know the pros and cons, or the kind of connectivity you think remote sensing, because I also know that you have expertise in that aspect as well. And we know that the ocean is a constantly changing environment, never really stable for too long. So I'm curious about knowing the pros and cons of using satellite imagery to complement traditional methods of remote sensing. Thank you, sir.
Yeah, thanks so much, Paul. That's a very great question. And as you mentioned, yeah, we can leverage that. And the advantage of remote sensing is we can get so much data in a limited time. So if you fly, let's say, a satellite or a drone, you can span a whole lot of area. The traditional method we are using, you have to go out there and there's only so much you can collect. Unfortunately, remote sensing, you are way out there and you are sending magnetic energy, electromagnetic energy, and you are sensing the material. So for those without the background, remote sensing essentially is when you take a photograph. For example, let's say you have a friend standing at a distance and you take your phone and you take a photograph. So you are collecting data without being in direct contact with the object. So that's remote sensing. And you can see that the closer the person is to you, the nicer the image. If the person is standing very far away from you, you probably wouldn't even see them in the picture you take. That's exactly what remote sensing does. So because these microplastics are so tiny, and I mentioned like they are like the head of this pencil. So if you are way out there in the space, you may not be able to get it because they are so tiny. But there have been studies that have been able to look at the bigger one, the macro, so plastic bottles. Even that, it's hard to see individual plastic bottles from space. If they are collected together, and a good place where you have accumulation of plastics is near estuaries, right? So if you have the water from the rivers going to the sea, you see that a lot of material gets trapped there. Or if you are in a jar, I show an image. A jar is like the ocean current moving in a circular motion. So the materials are trapped in the middle and they just aggregated there. So you can see those bulk material, but individually it's hard. But it's not lost hope. Actually, one of the study that I know people doing here, and we are also part of it in our institution, is we are trying to see if we can have equipment that will get the materials right on source. So currently we have to collect the water or the sediment and bring it to the lab. But what they are trying to develop now is that this instrument will have cameras that will be capable of being able to identify the shape, the color, and size right out on the field. But it's still some way to go, but it's something that is being worked on. So for now, we cannot see microplastics from space. But with time, the technology being developed at a small scale where we can use it on river bodies. And if that works, it can be scaled up to using it from satellites. Yeah, thanks.
Paul, was your question answered?
Yes,
Anyway.
thank you. I got that. Thank you very much. Yes, sir.
Perfect. Thank
But
you,
I'm just,
Professor.
can I just,
We'll take,
okay.
okay. If you want to make a comment, that's fine.
Okay, no, I'm just, you mentioned the aspect of optical sensors and optical sensors, and I think radar remote sensing, and you said they are not currently able to sense microplastics. So I'm just curious, like, does that mean that currently there is no how do I say, like, any remote sensing technology that is being actively used in the body of research for for plastic studies generally? And if there are, please would like to know about these available techniques. That's
Yes.
what I'm curious about. Thank you, sir.
Yeah, thank you. Yeah, so for microplastics, no, because they are too tiny. But for the bigger plastic, like plastic bottles, even that not individually, but it has to aggregate, right? So if they accumulate at estuaries where they are coming in droves, or in a jar where they may call Sentinel-2, for example. Sentinel-2 is a type of satellite that has very high resolution and is able to descend between land and then ocean and then the materials in it. So Sentinel-2 have been used to look at the debris, the bigger plastic that have accumulated, not individually. And then there are research that are using like cameras, but those are not satellite. So let's say my local community on the highway where you have like a bridge, right? And the water flowing, you can install a camera there and that can look and that can get the plastic, even though not the micro, the bigger plastics, because you are not far off from the material. But out in space, we don't have any satellite that are measuring microplastics. But Sentinel-2 can be used to measure the bigger plastics bottles that accumulate together. Yeah. Hope that clarifies it. Thanks.
Yes, sir. Thank you, sir.
Thank you. We'll take the next question. Georgina, please, you can unmute and ask your question.
Hello, good evening. Can you hear me? Am I audible?
Yes, you are.
Okay, Adejoke, thank you for convening this meeting. Professor Eben, thank you for your very informative session. Before I say a word, I want to appreciate my boss that is writing this meeting, that actually gave us the link and the opportunity to be at this meeting, Professor Lawrence Ikechukwu. Thank you, sir. So my contribution will be, yes, we've been talking about microplastics. Microplastics are actually increasing in their concentration in the environment because of the importance of plastic itself. Plastics are so important, and the use is increasing because of their importance. So now we are looking at interventions. I appreciate all the interventions you have come up with. But I think one pressing intervention that comes to my heart a lot of times is focusing on biodegradable plastics. I think the world is now talking about green plastics, because if we told that direction, I think the environmental effects of plastics will actually narrow down, will reduce, because we're not focusing on green plastics. Another intervention I think will be important in Africa is policy intervention. I think the control and regulation of plastic is not very effective yet, because government is not coming up with, is not enacting policies and laws to regulate its use. I think that's why the concentration of plastics in the environment is increasing. Notwithstanding the use, if there are regulations to control the use of plastics, I think the concentration of plastics will reduce. And if researchers will go into researching on biodegradable plastics, materials that are used for plastic synthesis or manufacturing, that will help degrade bioplastics, degrade plastics in the environment, that will directly reduce the concentration of microplastics in the environment, thereby reducing the negative effects of microplastics in the environment. I just need to say that. Thank you very much. And I'll be glad if you can also share your slides with us. Thank you.
Yes, sure. I'll share that with Mrs. Ade. Okay. And thanks for the input. With regards to biodegradable plastics, yes, it's been thrown out there and they've been talked about it, but it's still something way to go. And some have even questioned if it indeed is biodegradable, because plastic by itself is man-made, right? It's chemically synthesized. And the chemist will tell you that once you do that, you're basically going to change it from one state to a different state. So you may not eventually erode it as something that is organically made. So it may be promising, it could help us reduce it, and there have been some research, and I agree we need to do a lot more. But then they've also even been mentioned of having some bacteria or of a sort that could feed on these plastics and all. But that is, you're trying to patch up a wound more or less. Because those bacteria that you are going to introduce into the environment, our biologists will tell you, you may end up also creating invasive species. So it may work in one area because they may not have maybe something, a host or something that they feed on. But if you take it to a different place, they could eliminate disrupt the ecosystem that is prevailing there. So there will be a lot of solutions that have been thrown out there, and then they are being examined. But of course, going forward will also take something that you mentioned, policies. And I mentioned Rwanda, for example. If you go there, Kigali is very, very clean. You not even believe you are in an African city. And a lot of our cities, especially in West Africa, we are not doing too well. Ghana, Lagos, Abidjan, we are not doing too well in managing our waste. So you need very stringent, and it has to be, it needs a lot of strength politically to be able to do that. Because plastics is very tempting, as you mentioned, because they are very cheap to make. They are malleable. You can change them to any form you want. But if you want to introduce like paper bags and all, it's going to be a bit more expensive. And your people are going to start crying. The traders that sell with plastic, the food vendors and all, when you make a policy that eroded, they will threaten you that they are not going to vote for you. And our politicians, a lot of them will go after the vote, so do not care. So it needs a lot of political will to be able to implement those, and we need to do a lot more. And that's why institutions like this or conversations like this are very important, so that the NGOs, they can put in a lot of work, because they have a lot of voice. Some of our professors, a lot of them are in state-run universities, and we know how our politics is in Africa. You start talking and it seems to go against the government and you'll be targeted. So they tend to hold that back a bit. But the NGOs may have a lot more voice than the private sector. And individuals, if we stand up as a community and then we tell our politicians that, hey, this is something that we are very careful, we are serious about, because harming is potentially going to harm our children yet to be unborn, our environment, and then the fish and the food we are getting from our water bodies, they may probably start taking us very serious. So I agree with you, Ms. Jordan, we need to do a lot more. Thanks. And I want to acknowledge Professor Lawal Are, who is here. Thank you, ma'am, for joining. Great to have you here.
Thank you, sir. I'm happy that I studied and I enjoyed your session. So I hope one day we'll be able to do research on microplastics in the surface. We want to go away from the fish. We'll be doing fish. So let's do something on shellfish. I'll be glad. I have seen somebody interested in it. So hopefully we will make it work. Thank you, Prof. Well done, sir.
Thanks, Prof.
Thank you so much, Professor Eben. Thank you, Professor Lawal, Professor Lawrence. Thank you to all the wonderful people, my colleagues from Poesin. I hope you've applied for the next one. It's happening in Ghana. Thank you so much for all my colleagues that joined and every wonderful person that joined this webinar today. It's been a pleasure having you, and it's been a complete honor to have each and every one of us here today. And I hope to have we can't have it enough, because if we have had enough of this conversation, then we'll be seeing a lot of change in our environment. But unfortunately, we've not seen the change that we've been hoping to see. But so we have to continue to have this conversation. Thank you for everybody that joined, and I want to just take 10 minutes of your time, if you would, in the chat room, because
Oh, I think her connection dropped. Yeah, so talking about that, as we mentioned, so are there any special initiatives going on in your local assemblies or communities which are trying to curb debris in our environment? Is there any nice initiatives going on that anyone can share with us so that people in other local assemblies can also copy? Anyone to share any special one going on? Yes, Stephanie.
Okay, good evening, Prof.
Good evening.
Good evening, everyone. So for me, right, it's a responsibility to talk to everyone in Nigeria about microplastic. So at the moment, every time I'm given an opportunity to conduct a beach cleanup, whether it's for an NGO or the NGO I manage, I ensure that we talk about microplastic so that people are well aware of what microplastic are, their effects. But Prof, I was going to ask a question. Now, talking with students, whether it's secondary, primary, or tertiary institution.
A little glitch.
Hello, can you hear me?
Yes, we can hear you,
Yes.
Stephanie. Please go ahead.
Okay. So your presentation is very beautiful. And I think, as always, catching the young ones early will solve a lot of future problem, which is why I work with children a lot. Is there a way we could make this very simplistic enough for us to be able to talk to the children or to the students at whatever level so that they get the idea? I give you an example. When we started talking about sea turtle, right? Getting the children to know about sea turtle got us farmers, fishermen in the coastal communities to begin to become aware of sea turtle. Because imagine if you walk into a coastal a coastal community and you're talking to a child, that child is going to be the fisherman of tomorrow. And then when they see a nesting ground, they already identified nesting ground. They see when their parents bring back those sea turtle, and there's been a massive improvement in the capture of sea turtle. So my question is, is there a way we can find a way of working together to make sure that these children, whether they are interland or coastal, can actually get this information so that tomorrow when they become policymakers, I like to rub it in as an economist, they can be able to make good policies that will protect both the environment and the ocean. Thank you, sir.
Yes, I greatly agree with you. In fact, children are a very good agents of change. And there have been a lot of studies to support this, that parents are very passionate about their children. So they are very likely to listen to them. So if children go home and in their conversation with their parents, talk about they being afraid of plastics harming their favorite cartoon characters, for example. If you watch this cartoon, Nemo, where you have the fish in the water and all that. That is an angle you can take it out from. Like you can have it, you go to the schools, you use things that they can relate to. If you show like those cartoons, or if there are popular local characters also in your neighborhood or country, you could use that as well. And then you make the conversation said that, look, if we don't stop what we are doing, these are friends that we see in the movies, they are all going to die and will not be able to enjoy them. That is something that will hit them hard. They will take their story back home, and then it gets the attention of the parent. So yes, children can be a great agent for change. And from that young age also, if you teach them these conservation principles, recycling principles, they grow with it, and then they change not just their colleagues, by environment as well. So we need to step up, and it's great. Some of these things we talk about are very technical, but this is where people who are more trained and more specialized in this area, like communication, and especially communicating to younger people or non-scientists, this is where we need to work together with them so that we can tell them this story, and then they'll be able to convert it to a way that is very easy to understand for non-scientists, for non-policymakers, and for children. So we need to work together with different people who have the expertise, so they will help us to develop these materials. So that's something that usually, like the older or more technical folks, we tend to miss that mark. That's working with people who are more specialized in areas that we are handicapped, so that they can help us to tell the story. So that is one angle that I think we can take it from. Yeah, thank you.
So,
Thank you, Dr. Stephanie, for your question. I had a bit of an internet glitch a while ago. Thank you, Dr. Iben, for answering that question. We do have people who are, interested in early child education and also know the importance of, exposing children early to these environmental issues. And we hope that people will take it up. We have someone within our organization who is passionate about that. Thank you so much, everyone, for joining. Like I said before, if you want to share if you want to share your LinkedIn in the comment section, you can take like 5 minutes to do that. Let's, share LinkedIn. Let's network so that, we can come together and do something great. While we're doing that, I would like to again talk about our organization in case for those of us that joined late. This is Cleaner and Healthier Nature Initiative. It's a youth-led organization in Nigeria, and it's focused on environmental sustainability and environmental health. And our mission is to build a cleaner nation with healthier people by promoting sustainable practices and activities across communities in Nigeria. And the reason why I talked about the importance of networking is because I and my partner, the co-founder, we were students in Unilag, and we came together. We did our MSc in University of Lagos in 2020. We started in 2020. And we met, and because we have like minds, we started this organization. And since 2021, we've been doing these webinars every month, non-stop, even on days where we have just 5 participants. So thank you, everyone, for joining us. We've come to the end of this wonderful session. A very big thank you to our guest speaker, Professor Iben. Thank you so much for honoring our invitation, and thank you everyone that joined. It's a pleasure.
Yeah, thanks for having me, and you have a good weekend.
You too. Bye-bye. Thank you, everyone. Happy Easter. Have a great weekend.
Thank you.
Good night, Adejoke. Thank you for this session. Have a wonderful
And I am your
celebration.
host. My name is Adejoke Ayoade.
This thing is
Thank you, Professor Iben, for the presentation and the organizer of this program. Thank you.
Thank you, ma. Thank you, ma.
Yes, ma'am.